All right, I think we're ready to go. Thanks everyone for making it out here. I think this is probably the farthest outpost in reInvent. It's the last session of reInvent. I believe this is the last time slot, which is great because it means all of you really were interested in the topic, and we appreciate that. So thank you all for coming. We're going to spend a little time today talking about something that probably is at the top of each of your company's agenda for the upcoming year, which is how to cut costs and how to do so with as little effort as possible. Specifically, we're going to talk about the opportunity to cut costs maybe by as much as 30 to 50% by migrating some of your general computing workloads over to ARM-based instances on the Graviton fleet at AWS. Today, I'm joined by Charity Majors from Honeycomb, the CTO of Honeycomb, and Will Koplitz, a senior solution architect specialist at AWS from the Graviton team. And we're gonna take turns coming up here talking through the process of what it takes to think about migrating to Graviton and how to go through the steps. And Charity has gone through these steps, and she'll be able to talk in detail about what it took for her company to be able to do so. So we're gonna split up the presentation today under three themes or three topics as we go through. The first one is really to kind of set the table for why this is a fairly unique opportunity. And we'll talk about the challenges of software today and making changes and looking for optimization opportunities within software today. Then we're gonna move to talk about the tools and the strategies for how to go about thinking and planning for a migration over to an ARM-based fleet. And then lastly, as I mentioned, we're gonna have Charity talk through the steps that her company went through, the results, some of the challenges and obstacles they faced along the way, and how they overcame those, and what the end results were of going through that process. And then we're going to leave time for Q&A at the end, because we found that there's always a lot of good questions on this topic in particular, so we're going to make sure we've got enough time to do that. So, software delivery today, what exactly does it represent? I mean, probably most importantly, I think everybody would agree that speed is essential to software delivery and modern software delivery in particular. The evidence and the data to support how important it is to be able to look for speed and to look for every opportunity that you can take advantage of and put it to work for your company is pretty compelling. 4 to 5 times revenue growth multiples, 60% better shareholder returns, 20% increase in operating margins, 55% increase in innovation. It all sounds really fancy. It ultimately means that companies that do adopt modern practices and look for these edges continuously do much better than their peers that don't. So the problem that we all face in software today is ultimately that we all want to move faster, but it can be really hard to do so. The opportunities to do so span quite a few different realms within the end-to-end software delivery flow, from the coding part of the process to build, test, deploy, release, and then the runtime environments. All of these areas have their own unique complexities and their own opportunities to take advantage of. And so it can be a really complicated subject to try and tackle. And so what we've done is think about, well, actually, let me take a step back and let's talk through how has software evolved over the recent years, and why has it led to, why has it proven more and more complex for all of us to kind of find these opportunities and put them to work? If you think back to kind of the original method of software, it was all based on a single monolith that you controlled everything within your applications, within the code base, within operations. Everything was code that was written by the organization and by the dev teams themselves. Then open source came along. We started to incorporate open source components into those things. Then microservices became an interesting opportunity to break down the units of software into smaller pieces that were easier to change and to manage independently. And then lastly, the idea that some of those microservices that you may have designed and built inside your application don't even have to be run by you. You can connect to third-party services and make these available and essentially make them part of your application. All of this has ultimately led to a trade-off for the greater control and speed that you get from those changes that have evolved over time. You also get a lot more complexity. right? Even though monoliths have their disadvantages, one thing they did have is that it was a single unit that you can change and deploy and manage. It was fairly straightforward. With all of the breakdown into smaller and smaller pieces, third-party services, open source components, managing all of that change has become quite complex. And it means finding opportunities to achieve cost savings, to achieve greater efficiencies within your application environment become more difficult because you're looking over a much larger surface area of components and areas that you've got to be able to keep track of and manage, I guess is the best way to say that. So all of this just really means it's really hard, right? Trying to get to finding these great opportunities to make your applications, their environments, have these kind of stair-step improvements in efficiency and productivity and cost savings becomes really difficult. I guess if you wrapped up in one phrase, it's that doing anything in software has become increasingly difficult. So how does that usually show itself, in your world when you're taking a look at your applications and figuring out where to find opportunities? Ultimately it comes down to we're trying to deliver speed, but we're also under a ton of pressure to produce those improvements as fast as possible. So there's just a constant pressure to provide short-term benefits and constantly scale and improve. From a scaling perspective, with all of those components and all of these third-party pieces that are now part of the world, keeping visibility into everything that's happening there has become more complicated. And then lastly, it's a complicated world. We all make decisions on things to spend our time on. We're always making essentially educated bets on what an investment might return to us in terms of its opportunity. And so making the right decisions and getting all of these three variable vectors correct is kind of important if you're going to achieve these kind of returns that make the improvements that you make give you the benefit that you were seeking from the get-go. So we do have good news. We're here today to tell you about an opportunity that should be quickly available to each of you and for your existing applications. So basically saying all that difficulty that exists in the world of software that we work on today, it's pretty rare that you get an opportunity that is fairly straightforward to take on and has significant returns. And so I guess my promise to all of you is that within 30 days, I think you could be going back to your organization and you could be taking advantage of what we're talking about here today and be somewhat of a champion for this opportunity back at your organizations. So I'd like to bring up Will now from AWS and the Graviton team there at AWS. And he's going to talk about how AWS has enabled this opportunity through Graviton and through the fleet opportunity that they've brought together. So thanks, Will.
All right. Thanks, Tom. So I'm Will Koplitz. I'm a senior specialist solutions architect with AWS focusing on Graviton and ISVs, so independent software vendors who are trying to move their particular software offerings from x86 to Graviton. So this is probably not news to everyone here, but AWS has the broadest range of instance types of any cloud provider. They're with over 500 of them based on different types of compute, memory allocation, if you need IOPS-intensive instances, as well as the type of storage that you can use as well. We launched 2 more instances this week, so keeping up with the number is always a bit of a challenge. And we also have the broadest choice of processors. So we have Intel, AMD, and our own processor as well. So Amazon is a lot of different things to a lot of people. It is trucks on the road. It is Alexa not understanding what you're saying to her. It is also a chip company. We've created our own silicon, and we've designed this specifically for AWS. And what is great about this processor, it's an ARM processor. If you have one of the newer Macs, M1 Mac, you may have noticed that the battery charge lasts forever, and it doesn't heat up on your lap. You can actually use it as a laptop. And those types of changes were brought about by using the ARM architecture. We have taken that architecture to the cloud. So many other chips that are in use were not originally designed for the cloud. Graviton was born in the cloud. So we know what works for our customers. We try to continually improve for our customers. And this enables us to do so to lower cost. So each instance by instance type, it is 20% cheaper to use a Graviton instance to a comparable instance with the same amount of cores, same memory, same IOPS. And it also gives 40% better price performance. Part of the reason for this is that unlike x86, there are physical cores on the machines, so there's no hyperthreading. When you're using a CPU with hyperthreading, you can reach a point of contention around 60% where the latency of operations begins to increase. Graviton, with physical cores, can run much hotter. So instead of scaling out your workloads at 60%, you can scale them at 85%, for example. And my favorite part of all this, I mean, when you talk about chips being faster, yeah, Moore's Law, we've all heard of it. That's not anything new to the people in this room. But when you hear about it using 60% less electricity as well, that really catches my attention, at least, as someone who lives on planet Earth. So I hope other people as well are interested in saving some electricity. So you have a chance. This is a rare chance in the history of cloud computing, for example, where you can make some configuration changes in your CI/CD pipeline, lower your cost, increase your performance, perhaps lower the amount of instances that you're using as well, and also lower your carbon footprint. So it's a chance for a developer or someone in CI/CD or a director of technology, for example, to really be a hero or heroine, whatever the case may be. So with that, I'd like to pass this back to Tom, and thank you for your attention.
All right. So how do you do it then? So this is the big reveal, right? Migrating general computing workloads over to ARM-based instances can get you significant cost savings right now, especially in a period where all of us are facing cost pressure in the current environment. So you got to start with the right foundation. Ultimately, when you think about migrating a general computing workload over to an ARM instance, the first thing, of course, you think about is the production environment. How are you going to run these on ARM instances? But it's just important to think about the rest of the value chain, the software delivery chain, from coding to build, test, deploy, and release, and ultimately running. And that's where the right foundation enables you for success here. And so, regardless of the VCS system, the VCS systems are largely unaffected by trying to make a change like this. So really, whichever one you're working with today is going to likely fit and be a good foundation for you with an effort like this. But then that build, test, deploy, release opportunity, this is where CircleCI comes in. And obviously with the run, what Will was talking about, AWS providing the scalable EC2 ARM-based instances really enables the ability to run these at scale, at the largest scale, really available anywhere. So the steps to migrate an application over to an ARM-based instance actually follow directly the pathway of that software delivery value chain. So initially, you've got to, of course, compile your application to run on an ARM-based instance. You're gonna either cross-compile or make sure essentially that all your dependencies and everything else are going to work. The great news is the ARM Foundation has been working diligently over the last decade to make sure that all of those dependencies are just going to compile out of the box without any issues. And so you can build that right into your CI/CD processes so that everything you do today to build, test, deploy, release are all available to you as part of an automated CI/CD pipeline. And so testing your code, of course, quite important to be running that whenever possible on the same architecture that it's going to be running in production. And so, an important element here of which CircleCI makes that available to you. And then, of course, as I mentioned, as you go through managing your deployment, if you've got special scripts that you've created in order to deploy into the current environments, you'll need to update those scripts and make sure that they still work in your new environment. And of course, you can automate those through your CI/CD platform as well. And then, of course, the same thing with release. So what's happened here is CircleCI AWS have partnered to make sure that we really have a service available to you to be that foundation, so that when you do decide to go take advantage of those cost savings that are available to you by moving your production instances over to ARM-based Graviton fleets, then you also have a CI/CD service to support you in that process, so you're not trying to figure out how to make that happen while you're migrating these applications. And so, we talked about AWS providing the scale that you need to be able to manage this at really any workload size, and we talked about the price performance. It's significant. On the CI/CD side, CircleCI as a Graviton-ready partner is the only managed service currently available to help you with that process. And so essentially, we manage build fleets on the Graviton instances at AWS entirely for you as a managed service as part of our multi-tenant SaaS solution. And so it ultimately means you don't have to worry about that. You don't have to worry about setting up your CI/CD infrastructure. You don't have to worry about anything other than just getting your configuration in place and letting us take care of all the inner workings behind the scenes. And of course, with CircleCI as a multi-tenant SaaS, like AWS, we also support all of the other architectures as well. So if you're going to continue to build in a cross-architecture mode, either because you're going to transition over time and slowly migrate workloads over fully to ARM, or where you're going to continue to run and build and compile for multiple architectures, you can do so entirely in parallel within the same pipeline and the same triggering event. So I just want to point this out. It probably seems like a little bit of a small detail, but all it takes to convert in your CI/CD system on CircleCI from an Intel-based workload over to a Graviton-based workload in your CI/CD is that one configuration change. It's that simple. It's really just go and update the resource class that you're going to be building upon, and it'll start running and building your software. And so I just want to kind of summarize CircleCI and AWS Graviton, the only Graviton-ready partner with that managed fleet. We have these ARM-based now available inside your pipelines. You can also build behind your firewall if that's required inside your environment. We've got runners that run on those ARM-based instances as well, so you can orchestrate from the cloud, but also be operating the actual builds themselves inside your own VPCs on machines that you manage, but connect into that orchestration. You can run in as much parallel concurrency as you'd like to. So we have a customer that splits their tests across 140 parallel jobs and took their builds that run from, I think they were running at around 56 minutes, and it took them down to somewhere between 4 to 6 minutes on average because of that parallelization. A massive benefit to keep your developers in flow and productive. And of course, all the benefits of moving to an ARM-based workload that Will talked about, the price performance, the sustainability, and the performance itself with the multiple CPUs across jobs. So the results then ultimately, what can you expect if you go through this process? Ultimately, it does streamline the migration when you've got the right foundation in place. It does reduce your costs. And if you do have projects if you're a startup or an open source project, we actually have special benefits for those situations as well. And so if you do have any questions, you can see me afterwards. We can talk about that. But what I'd really like to do now is turn it over to Charity Majors, the CTO of Honeycomb. She has been through this process, and she's going to walk you through the steps, the challenges, and the successes that she ended up having as a result. So, Charity.
All right. Testing. Woohoo, test succeeded. Well, it's actually a little unfortunate that it's me here. This is Liz Fong-Jones's work. I am really presenting all the work that she's done and she's talked about. I don't play Liz on TV very well. We have very different styles, but I will try and represent her work as best I can. Oh, wow, it is the last day, isn't it? Because I have lost my voice. How Honeycomb scaled using CircleCI and Graviton. So for those of you there's a lot of people here considering that it is this late in the last day. All right, isn't there a party somewhere that you should be at? Well, for those of you who don't know what we do, somewhat relevant, actually, so let's talk about it super briefly. We were kind of the pioneers of observability. which is, a socio-technical approach to understanding your software in production through instrumentation and, high cardinality, high dimensionality, blah, 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 blah. If you care about that, there's other talks and shit you can, other talks and things you can read about that. And observability is, it's obviously very important for people who are building software in kind of the modern era. It's also like it's under the hood. It has very high demands, right? Over the last 3 years, we have 10x'd pretty much everything. The amount of data that we have, the amount of traffic that we have, and meanwhile, we have our team of engineers increased not at all. And our guarantees to our users, our SLOs, are pretty ambitious. We require like 90% of all queries to execute within like 5 seconds. So we need it's pretty important to us to stay kind of on the cutting edge of technology, and not just technology, but socio-technology. We have a philosophy around getting your production changes live as quickly as possible that we kind of affectionately refer to as 15 minutes or bust. From the moment that you merge your diffs, it should, kick off a CircleCI worker, run through all of the tests, spit out an artifact, and then notice that there's a new artifact and deploy it to production. But really, you want to treat production as much like a REPL as possible. That's the goal. And that's how we've managed to do so much with so few engineers. We're going to be 7 years old as a company in January. For the first 5 years, we had 12 engineers, maybe 30. Now we've got 50. But you can do a lot if you aren't constantly waiting on each other. And the more people you have, the more problems. Anyway, this is a graph of, stuff going up, et cetera. Our challenges, the one that we're going to talk about today is the specific challenge that we had when we were trying to deploy Graviton. Now, you saw a bunch of statistics about how Graviton is faster, cheaper. All these things are true. But this was the very early days, and nobody out there was really using it. So we didn't really just want to YOLO it. I mean, that can be fun. but we wanted to actually, do this with some science. We needed to have, two CI/CD pipelines effectively. Every time we submitted a diff, we wanted it to, run, test, build an artifact on, the old hardware stack, the old hardware, and one on the new ARM stuff, so that, because we want to run both in production for an unknown amount of time, right? I'll talk about that later. So one of the things that made this possible was, CircleCI's support for ARM and their support for parallelism. If you don't have those two things, if you think about it, what a nightmare is it going to be to try and, run two different, run the same code in two different, hardware stacks like indefinitely? Are you going to be like flipping your configs back and forth every time you run them? Are you going to like run one off of somebody's like server under their desk? Like there's really no good options if your tool chain doesn't support this all the way down. And it sounds so basic, but if you don't have it, it's not basic at all. It is a traffic light that stops you in your tracks. So that was pretty dope. What it looks like for us, I'll explain this a little bit. Gaining confidence in production is how we think of deploys, right? Deploys are not a moment in time where you're like, woohoo, it's live. It's more like, okay, we're putting our changes into production in some form or another, which is really the moment in which you begin to build confidence in your code. That's it. You can't begin to build that confidence until people are using it in production. And once people are using it in production, you're not done building confidence until it's baked. 10 years later, maybe you can go, okay, this code is great. So we have multiple environments. None of them are called staging, you'll notice. what these arrows mean are, so you've got your CI/CD artifacts over there on the left. Production, the instrumentation from production gets shipped to our dog food cluster. So we can look at dog food if we want to understand production. And the instrumentation from our dog food cluster gets shipped to kibble. So we can look at kibble if we want to understand our dog food production, our dog food traffic. But when we're deploying stuff, it goes in the opposite direction, obviously. When we merge our diffs to production, or merge our diffs to Git, it kicks off the build, blah, blah, blah. The artifact then gets pushed to kibble. And, because it's a real, people are using kibble every day, right? Because we're trying to understand stuff. So it gets shipped to kibble, and then we let it bake for an hour or so. And if there are no problems, it gets automatically promoted to dog food. And we let it bake for an hour or so. If there are no problems, it gets automatically promoted to production. And I think this is really important because you want the right thing to happen by default. You don't want there to be manual steps in here somewhere that means somebody has to go remember to make a decision to do a thing, right? You don't want it to be a situation where you're like, yes, do something. You want it to be in a position where you only have to say, no, don't do something, right? That's how you construct a healthy build pipeline that lets you have a very high velocity of development. So, starts in CI. Here is the actual CI config we have that supports multiple architecture builds. Cool. So next I'm going to show you some graphs that show us rolling out the Graviton changes to first our ingestion service and then to our database. Woohoo! The funnest changes of them all. By the way, never write a database. Do not write a database. Do never, ever, ever write a database, except when you have to write a database. So here's the ingest path. So the orange one that you can see there is the x86. The purple is, of course, Graviton. So you can see that we turned it on for a small percentage of our traffic. We started looking at all of our other graphs and stuff. We realized that there were some issues with, I don't remember what it was exactly. Something wasn't looking super kosher. So we rolled it back. By rolled it back, I mean we flipped a little feature flag because we're not cavemen. We flipped a feature flag, switched it off, made some changes, flipped it on again. When things started looking good, we just flipped it all over. And I guess this is kind of the same thing. This is the UI feature flag case. Like, we didn't want to lock people out when there were bugs, et cetera. So, I think this is from the what? Oh. It was from the column builder thing. I'm blanking. Oh, my brain is gone. Whatever. Green. Yeah, the yellow is the old and the purple is the new, and you can infer the rest. But here's the really interesting one. AWS Lambda. So when you're talking about the database, and if pressed, I will insist that we did not write a database. We wrote a storage engine. And the query planner for our storage engine actually consists of a bunch of Lambda jobs, which is pretty dope, right? Because it'll go out and it'll scan like S3 and like all of the SSD stuff. So AWS Lambda, you can see the percentage. We start sending a small percentage, we start sending a larger percentage. I wish we had included a few more of these graphs, actually, because it was quite the dramatic deploy. Because first, we kind of did YOLO it a little bit. Like, Liz was like, let's flip the flag on for 50%. And we ran it for a while. And, nothing catastrophic happened. But we noticed that median latency was, higher. And the funny thing was that, honestly, none of this was really visible from a user's perspective. A user can't really tell if their massively parallelized query is executing and returning results in 0.5 seconds or like 0.7 seconds. But given that Lambda charges you by the amount of seconds that it's running your jobs, holy shit, holy crap, our bill, ooh. So we were like, pull it back, made some more changes, flipped it on again with a smaller percentage of traffic this time, looked okay, so we rolled it out. Retriever is what we call, all of our backend services are named after dogs. So like Poodle is the front end, API is a shepherd, Retriever is the data storage. And overall, after switching from x86 to Graviton, 10% reduction in median latency. The stuff is great. For us personally, we scaled 10x over 3 years, constantly doing, more with less. I know a lot of teams take pride in growing and getting big, but we take a lot of pride in doing a lot with a few people, and not burning them out, of course, but like having actual work-life balance. The cost savings is a really like eye-popping number here. This is all great. And the thing is, the last opportunity that we as technologists had an opportunity to have such a big impact with so little work, the last thing that comes to mind was when SSDs came out in 2008, 2010 or whatever. I remember spending a year on a MySQL upgrade where, trying to go from 4.1 to 5.0, and we did the upgrade, and oh no, all the benchmarks said it would be faster, but it sure wasn't faster for our workload, so we had data loss, we rolled back. Spent a whole year building this framework to do, capture and test, one version, tweaking the, I'm sorry, I filters, tweaking the hell out of the configs, running, parallelize over all the compute, and I did all this work, and the upgrade went seamlessly, and yay! And 6 months later, SSDs came out, and all of it was pointless. All of it just didn't even matter, because SSDs were just you didn't even have to worry about data localization on spinning Rust anymore. It's just it was like magic. And Graviton feels like magic to me, right? It's you flip a little config file, test it a bit depending on your tolerance for errors, but or for latency, et cetera. But it's rare that you get optimizations and savings like this without really doing any engineering whatsoever. So I think it's pretty exciting. Precision is what gives you confidence. So, this is where if I was doing an observability talk, I would start ranting at you about instrumenting your code and observability and all those things, but it is a CircleCI and AWS talk about Graviton, so I'm just going to say how exciting it is to actually, our bill dropping by that much with no work was just amazing. I think that's it.